Okay, today we are going to start with the design analysis of an algorithm. So, what is an algorithm? It is nothing but a step-by-step process to solve a particular problem. So, algorithm must be finite. It cannot be infinite, right? If you are having infinite step to solve a single problem, then it is of no use. It should be a finite algorithm. Let's say we have making an algorithm to add two numbers. So, what will be it will be? We will have few steps, right? We will take A as input, we will take B as input. We will add both of them, okay, save it into a variable and print the value, right? So that's a step-by-step procedure to solve a particular problem. So algorithm is a well-defined computational process that takes some values or set of values. So algorithm must take an input and also it must give an output. Okay, it must produce some values as an output. So we are algorithm is a step-by-step process of formula for solving a problem which defines a set of instructions to be executed in a certain order to get the described output. Algorithms are generally created independent of underlying language. Okay, तो अपने को यहाँ पे केयर करने की जरूरत नहीं है whether we are making Java, Python, C++, any language we can use. Okay, algorithm is independent of the language. Example, the different ways algorithm used today. Algorithm helps control traffic lights. Computer use algorithms to convert data, okay, convert decimals to binary. GPS use algorithms to find the best route for destination. Smartphone, Wi-Fi, wireless communications use algorithm to communicate. Characteristics of algorithm. Note, all procedures can be called an algorithm. Not all procedures can be called as an algorithm. An algorithm should have following character. Algorithm में कुछ characteristics रहना. क्या है? Input रहना algorithm का, output रहना, finiteness रहना, okay, independent रहना, ambiguous रहना. या मतलब के algorithm कनेक्ट भी रहना. ऐसा नहीं रहना you are adding two numbers मगर आप वहाँ पे डाल दे रहे a plus b plus d into 3 बोल के, तो आंसर वाला तो देंगे ना, because algorithm क्या है? It is to add two numbers. Okay, it's a step-by-step process to solve a particular problem. So what are the main things required for an algorithm? It should have an input, it should give an output, it should be finite, it should be independent, it should be ambiguous. So algorithm analysis. Efficiency of an algorithm can be analyzed at two different stages: before implementation and after implementation. There are priority analysis and post priority analysis. This is the theoretical analysis of an algorithm before the algorithm is executed. The behavior of the algorithm and the analyze it concentrates on determining the order of the execution of statement. Efficiency of the algorithm is measured by assuming the factors as producer, speed and half numbers effect on the implementation. Post okay, ये वाला पार्ट मैं छोड़ दे रहा हूँ. Space complexity पे देंगे. Space complexity. When we design an algorithm to solve a problem, it needs to have some computer memory to complete the execution. For an algorithm, memory is required for the following purpose. Memory required to store programs, instructions. Memory required to store constants and variable. Memory required to store variables, values, and for other reasons. Okay, memory required for storing programs, instructions. The total amount of computer memory required by the algorithm to complete its execution is called as space complexity of the algorithm. Space complexity is divided into two parts: fixed part, variable part. Fixed part, it is a space required to store certain data and variables at are independent of the size of the problem. Simple variable, constant, program size, etc. Variable part. It is the space required by the variable whose size depends on the size of problem. Dynamic memory and space. Time complexity. Every algorithm requires some amount of computer time to execute the instructions to perform the task. This computer time required is called time complexity. It can be defined as a follows. The time complexity of an algorithm is total amount of this time required by the algorithm to complete this execution. To calculate time complexity of an algorithm, we need to define our model machine. Let us assume a Moore machine follows the configuration. Single process machine, 32-bit operating system machine. It performs sequential execution. It requires 1 unit of time for arithmetic and logical operation. It requires 1 unit of time for assigning and returning value. Requires 1 unit of time for reading. Measure of time complexity. Best case. The amount of time the algorithm takes on the best set of inputs. Inputs are provided in such a way that the minimum time is required to process them. The best case is for sorting algorithm would be data that is already sorted. The best case कितना अच्छा है, देखो ऑलरेडी सॉर्टेड डेटा है, इसको सॉर्ट करो बोले तो खत्म, सॉर्ट हो गया. इसको बोलेंगे बेस्ट केस. The best case complexity of an algorithm is the function defining by the minimum number of steps taken on any instance of size n. It represents the curve passing through the lowest point of each column. Average case, best case, average case, worst case. The amount of time the algorithm takes on an average set of inputs. The average case complexity of the algorithm is the function defined by the average number of steps taken on any instance of size n. It is arithmetic mean run the algorithm many times using the many inputs of size and that comes from some distribution that generate these inputs complete the total runtime and divided by number of trials. Worst case, the amount of time required taken by worst set of inputs. It is lowest time to complete the input. The worst case complexity of an algorithm is the function defined by the maximum number of steps taken on any instance of size, the representation of the curve passing through the highest point of each column. Input size. Program can be expressed as a function of size input. The size input is typically denoted in n, runtime of an algorithm. Asymptotic notation बहुत important है. देखो growth order क्या है इसका. Asymptotic notation of an algorithm is the mathematical representation of its complexity. In this, when we want to represent the complexity of an algorithm, we use only the most significant terms in the complexity of that algorithm and ignore least significant terms in the complexity of that algorithm. Order of growth. 1 is less than log n is less than n is less than n log n is less than n square is less than n cube is less than till 2 power n. ओके, ऑर्डर मुश्किल नहीं है भाई. क्या है देखो, पहले 1 से शुरू कर रहे हैं. 1 के बाद क्या रहा, log n, फिर n, फिर n log n, फिर n square n cube, ऐसा चले आ रहे हैं. नाउ वी गो. तो क्या है, 3 टाइप्स ऑफ एसिम्प्टोटिक नोटेशंस है. Big O, big omega, big theta. Big O is used to define the upper bound of an algorithm in terms of time complexity. That means notation always indicates the maximum time required by an algorithm for all input values. That means O notation describes the worst case of an algorithm. तो बिग ओ क्या कर रहा, वर्स्ट केस बता रहा. कंसिडर अ फंक्शन f of n, okay, that tc of the algorithm, g of time consume of an algorithm, g of n is the most significant. तो इसमें क्या लिखेंगे अपन, f g of n मिलकर सा लिखेंगे और ये ग्राफ रहेगा. वाह, बिग ओमेगा मैं एक बार क्या करूंगा, गीक फॉर गीकनेस से एक बार अपन एक्सप्लेनेशन देखेंगे, बहुत इजी है. Disjoint set operation. In mathematics, two sets are said to be disjoint if they have no elements in common. The equivalent disjoint sets are sets whose intention is an empty set. A is equal to 1, 2, 3, B is equal to 4, 5, 6. Are disjoint set. Explain disjoint set operations using three. Let S is equal to 5, 6, 7, 8, 9, 10, 11, 12, 13. Be divided into three sets, 5, 6, 7, 8, 9, 10, 11, 12, 13. Array representation 5, 6, 7, 8, 9, 10. यहाँ से -1, 5, 5, -1, 8, 8, -1, 11, 11. ओके, समझ में तो नहीं आया पार्ट करें. Disjoint set ADT. I just want to skip this part. I don't know. टेंशन है तो बिग ओमेगा और बिग थीटा नेक्स्ट वीडियो में तुम देखेंगे. ई पर फैक्ट मालूम है ना. डिवाइड एंड कॉन्कर मेरा फेवरेट है. Divide and conquer. The problem is divided into small problems that each problem is solved independently. When we keep a subset problem into even smaller problems, we may eventually represent a stage where no more division is possible. We can understand divide and conquer approach in three-step process. Divide slash break. This step involves breaking a problem into small sub-problems. These steps generally take a recursive approach to divide the problem on sub-problem in further divisible. At the stage, sub-problem becomes atomic in nature but still represents some parts of the actual problem. Conquer and solve the steps recursively. A lot of smaller sub-problems to be solved. Generally, at this level, the problems are considered to be solved on their own. Merge as combine. When the small subsets of the terms are solved, these still recursively combine them until they formulate a solution of the original problem. The algorithm approach was problem divided into sub-problems, solve those problems and join them to make a solution. Simple. Binary search, quick sort, merge sort and STESS. Sorting algorithm. Sorting algorithm refers to the arranging the data in the particular format or order. Sorting refers to the representation of data in more readable format. Following are the some of the examples of the real life separations. Stable it if a sorting algorithm after sorting the content does not change the sequence of a similar content in which they appear are called stable sort. If the sorting algorithm after sorting the content changes the sequence of the similar context in which they appear, it is called as the unstable sort. In place stable, bubble sort, in place and stable, insertion, in place and stable, quick, in place but not stable, selection, in place but not stable, selection के बाद cell average, adaptive and non-adaptive sorting algorithm. A sorting algorithm is said to be adaptive if it takes advantages of already sorted elements in the use that it is sorted. Okay, while sorting, if the sort list has made some elements already sorted, adaptive algorithm will take this into account and merge sort if an effective general purpose component bus sorting algorithm